to New Science Practicals. I'm Miss Parsons and today we are going to be looking at neutralisation. So what I've got set up here today, you should be able to see the method on your practical sheet, is I have some alkali in both of these burettes. So what we call these is burettes. So we've got burette B here and burette A here, okay? And they both have different concentrations of alkali in. We have 0.5 molar, so 0.5 concentration in A, and we have 0.1 molar in B. Okay, so we have a stronger concentration in A than we do in B. And what we're going to see is how much of these alkalis we need to add into our acid to make it neutral. Now, if we relate this to a real life example, when you have heartburn or you might have acid reflux, okay, that's because you might have quite an acidic pH in your stomach. Now, what often people do is they might take a Gaviscon or a tablet called an antacid. Now, what they contain is an alkali. Okay, they contain an alkali that can then neutralise the acid that we have in our stomach. So what we're doing today is we're going to have a look at both of these alkalis and see which one is better at neutralising our acid that we're going to pretend is our stomach acid today. So what I'm going to do first is I am going to fill up both of these beakers. If I just bring these close to you, currently these are empty. I'm going to add some acid into both of these beakers, the same amount. I'm going to add 25 centimetre cubes of this acid. So we've got hydrochloric acid here. So we're going to add in some hydrochloric acid into our beakers. We're going to have 25 centimetre cubes into each of them, and then I will come back to see what we're going to do next. So before I forget, I'm going to put on my goggles and measure out my 25 centimetres cubed of my acid. Okay, lovely. Put that to the side. So I have my two measuring cylinders of 25 centimetre cube of my hydrochloric acid now. I'm going to add one into this volumetric flask and one into this beaker or conical flask, okay? So at this point in the practical, what I want you to do is have a think about what is the independent variable, what is the dependent variable, and what is our control variable. And I also want you to have a think about what your prediction is going to be. So I want you to predict which one do you think is going to neutralise our acid quicker. The alkali with the higher or the lower concentration. So remember, we've got one burette A that has a concentration of 0.5 molar, and then we have concentration of 0.1 molar in burette B. So have a think, do you think 0.5 molar or 0.1 molar is going to neutralise our acid quicker? Okay, so write your prediction on your worksheet. You should see there's a question that asks you to write your prediction, and then we will get started with the practical. Okay, so hopefully you've written your prediction now on that worksheet. Now I want to have a think about what our variables are going to be. So independent, remember, independent variable is the thing that I am changing. Independent starts with I, it's what I am changing. Now, the only thing that I am changing in this practical is the type of alkali, the concentration of the alkali that I am using, okay? We've got 0.1 concentration and a 0.5 concentration. So that is what I am changing, the concentration of the alkali. Now, the things that I am keeping the same for my control variable is the volume of acid that I am adding my alkali into, and the concentration of the acid that I am adding my alkali into, because we only want one thing to change. And then the dependent variable, the thing that I am measuring, is the volume of each type of alkali that I need to add into my acid for it to go neutral. Now have a quick think, what do you think I might add into my beaker of acid to be able to test the pH? So what do I use to test the pH of a liquid? So have a quick think. Now, hopefully from your lesson that you did earlier in the week, you will remember that we add a pH indicator. Okay, and the pH indicator that we're going to use is universal indicator. So I'll just bring that closer to this camera. So we're going to add universal indicator. Okay, we're going to add universal indicator into our acids. So have a think about what colour that might go. If I'm adding universal indicator into my acid, what colour does universal indicator go when it's added into an acid? So make a prediction before I add it in. So let's see if you're correct. So I'm going to add a few drops into here and a few drops into the other one. And then I will bring that up to the camera for you. So I'll give that a little swirl. Remember, we've got the same concentration of acid in both and the same volume in both. So if I hold that up close to the camera, you should be able to see that has gone a red colour. Okay, they've both gone a red colour. What's that showing is that they are an acid, and we knew that already because we added our hydrochloric acid into there. Now, have a think about what colour I'm going to be looking for when our acid has gone to a neutral liquid, okay? Because remember, that's what this practical is doing. We're looking at neutralisation. So make a prediction of what colour I'm going to be looking for when we've hit a neutral solution, okay? Now, what you need to have open is this worksheet. Now, this worksheet is the access sheet, and it's got a table on there, and it says indigestion remedy A and B. That's what we've got in our burettes. We've got A and B. And then we have the number of drops of A and B that is needed to neutralise the acid. So until our acid goes green. Remember, green on the pH scale shows neutral. Instead of drops, because we're going to have to add a few more drops, I think, I would change that to centimetre cubed. So the volume of alkali that we're adding, okay? Because I think it'll be a bit difficult to count how many drops we're adding. So we're going to get started. The first one I'm going to start with is A. Now, A was a 0.5 molar concentration. So that's the one that has the higher concentration out of A and B. Okay, so have a think. Do you think I'm going to have to add more of A compared to B or less? So let's see. So I'm going to add this really slowly, and I'm going to stir as I'm adding it. Okay. When there's a colour change, I will hold it up to the camera for you. So I'm just adding it really slowly and stirring as I'm doing it. Okay, I'm going to come and hold this up to the camera for you. So what you can see is it's gone to more of an orange colour now. Now, if I compare that to the original acid, this was the original acid, and this is the one that we've added some alkali into, we can see that there's definitely been a change there. We've not quite met neutralisation yet. It's still quite acidic. It's still got that orange colour, but it's definitely not as acidic as it was at the beginning. So let's carry on adding. So far, we've only added 4 centimetres cubed. So let's add a bit more. Okay, so what I'm hoping you can see now is we have a green solution. So if we look and we compare, first we started with a red solution that was showing a really strong acid. Now we've ended up with our green solution showing that it has been neutralised. Now if I read off my burette, okay, if I read off my burette, I've got to about 4.8 centimetres cubed. So I'm going to add that onto my board. So So 4.8 centimetres cubed was needed to neutralise A, and A was 0.5 molar, okay, that was a concentration of A. So have a think, B is 0.1 molar. Do we think we're going to need more or less alkali to neutralise this acid? Okay, so we're going to start with B now. So once again, I'll just bring it up to the camera so you can see. We have the pink, red solution showing an acid, and we're going to add our alkali in until it goes green again. So again, I will add it slowly, stirring as I'm doing that. Make sure you've made your prediction about which one you think I'll have to add more to. Okay, so I'm continuously stirring so I don't miss when it goes green. Okay, so it's starting to go more of an orange colour now. It's not quite as dark red as it was before. So far, I've added 16.5 centimetres cubed. So we're going to start adding it a lot slower now. Okay, so I'm at that orange colour again, like I was before. So start adding it really slowly until it goes green. I think we'll only need a few more drops. Okay, so hopefully, maybe 2 more drops. It's just gone yellow. If I hold that up now, you can see that it's that green colour again, okay? So you can see that we've got that green colour like we did before, so we've hit the neutralisation point, okay? So if we have a look at that one, I'm reading off 23.1 centimetres cubed, okay? So I've used 23.1 centimetres cubed with B, and I only had to use 4.8 centimetres cubed with A. So what I want you to have a think is, which one of those do you think would be better as an antiacid? Do you think A or B would be better? Do you think they would be sold more easily in shops as an antiacid? Okay, and I want you to think and write a conclusion to see whether that matches your prediction. Was what you predicted that was going to happen in this practical correct? Okay, so thank you for joining NUAS Science Practicals again. Hopefully you will be okay with answering the worksheet questions that come after this. If you need to rewatch the video, then absolutely feel free to do so. Okay, thank you for joining, and we'll see you next week for another video.